లాస్ట్ క్లాస్ మనము సోమర్ఫెల్డ్ థియరీ గురించి చదువుకున్నాము. ఇప్పుడు నెక్స్ట్ ఎనర్జీ లెవెల్ స్టేట్స్ గురించి కూడా కంప్లీట్ అయింది. ఇప్పుడు సోమర్ఫెల్డ్ థియరీ అయిపోయింది. టుడే we will see about vector atomic model. Today we will see about a vector atomic model. In vector atomic model, two types of quantizations is there. One is the spatial quantization, another one is spinning of electron. In spatial quantization, what is the meaning of spatial quantization? What is the meaning of spinning of electron? Now we will see that one. So today topic is, we will start from vector atomic model. Spatial, what is spatial quantization? What is vector atomic model? In space, according to Bohr, as per Bohr, we discussed last class. What Bohr said, Bohr is as per Bohr theory, orbits are quantized only in the magnitude. So the orbits are quantized only in the magnitude way, not in the directional way. But here, as per the quantum theory, what it is saying, the orientation is taking place both in magnitude. We are concentrating here magnitude as well as direction. We are concentrating on magnitude as well as direction. So it is quantized in both magnitude as well as direction. So only such type of orientations are quantized and only such type of orientations are permitted. Only such type of orientations are permitted. So according to Bohr theory, orbits are quantized in magnitude. Magnitude means we are concentrating on size. But as per the quantum theory, quantization is possible in space as well as in the direction. So the direction is here, we are concentrating direction in the reference axis. So it is quantized. If it is quantized in magnitude, direction, then we can say that it is quantized. Then it is orientations are permitted. So this spectrum line is applicable for Zeeman effect and Stark effect, both for electric field and magnetic field. This is for both electric and magnetic field. Next, we will see the spinning of electron. Spinning of electron means we are concentrating on the direction. Here we are concentrating on the direction. If one direction we will take +1/2, in another direction we will take -1/2. This is explained, the fine structure is explained by Uhlenbeck and Goldsmith. Introduce the concept of spinning of electron. So the spinning of electron is introduced by Uhlenbeck and Goldsmith. What he is saying, electron spins about the axis. Suppose this is an electron. It is spinning about its axis, both direction wise. And this is treated as one of the new quantum number. So this is, we are treating as a new quantum number. What is the new quantum number? S. So spinning of electron. When electron is revolving, it is not only rotates about the nucleus. Electron is not only rotating about the nucleus. This electron is rotating on its own axis. When it is rotating on own axis, I am using the term called spin. It is spinning. It is spin either in the positive direction or it will spin either in the negative direction. Positive direction is taken as +1/2. Negative direction is taken as -1/2. And here I am representing the new quantum number. What is this new quantum number? Is S. Based on this, vector atomic model is explained. In vector atomic model, we are concentrating on two concepts. What is the first concept we are discussing in vector atomic model? Principal quantum number. This principal quantum number is represented with n, and it is takes the values 1, 2, 3 in 4 like. So where all these are, we are n is an integer. Here n is an integer. N is the integer. Next is orbital quantum number. Orbital quantum number is represented with L. Orbital quantum number is represented with L. Suppose n equal to 3, then L equal to N minus 1. So if N equal to 3, what is L? 3 minus 1, 2. Suppose if L equal to 0, I am representing this with S orbit. If L equal to 1, it is P orbit. If L equal to 2, SP D orbit. L equal to 3, F orbit. L equal to 4, DF, EGH, like we have. So the next quantum number is spin quantum number. The next quantum number we are discussing, this orbital quantum number is L, I said. Orbital quantum number is represented with L, and notation for me, I am writing P of L equal to H by 2 pi under root of L into L plus 1. Next is spin quantum number. Spin quantum number is represented with what? S. And how many values it is taking? It is taking two values, plus 1 by 2 and minus 1 by 2. And what is the formula of spin quantum number? Spin quantum number is represented with P of S. P of S equal to H by 2 pi under root of S into S plus 1. Or another formula we can take, P of S is equals to H by 2 pi times of the spin. H by 2 times of the spin. And next one is total angular momentum. This total angular momentum is represented with J. J takes values L plus J to L minus J. Here, first what we saw, what is the first vector atomic model? First one we discussed. First one is N is over. Next is L, and orbital quantum number is completed. Next we completed spin quantum number. Next we are discussing J. J is total angular momentum quantum number. This J value lies between L plus or minus S. Here L, what is S? Only two values for S. Either it is plus 1 by 2 or minus 1, 2. So L plus or minus 1 by 2. Suppose L equal to 1. What we will get J value? If L equal to 1, we will get J is equals to 1 plus 1 by 2, 1 minus 1 by 2. 1 plus 1 by 2 is how much? 3 by 2. 1 minus 1 by 2 is 1 by 2. So J value is either 3 by 2 or 1 by 2. J value is either 3 by 2 or 1 by 2. Next, P of J. What is the formula of total angular momentum? P of J is equals to H by 2 pi. H by 2 pi under root of J into J plus 1. This is angular momentum. Next, we will see magnetic angular momentum. What we will see? Next part is magnetic angular momentum. Magnetic angular momentum is represented with M of L. This M of L take values plus L to minus L. Suppose my L equal to 2. Then what is M of L? M of L equal to 2 plus 2 to minus 2. This plus 2 to minus 2. So what are the values? Minus 2, minus 1, 0, plus 1, plus 2. These are M of L values. Minus L to plus 1, or else another formula we have, or else what is another formula? 2, it takes 2L plus 1 values. How many values it will take? 2L plus 1. Suppose L equal to 2 means 2 2s are 4 plus 1. Total how many values? 5 values. Just cross check. 1, 2, 3, 4, 5. So this ML is taking 5 values. What is the formula? 2n plus 1. Next one is m of, next one is m of s. Next one is m of s. M of f is the magnetic spin quantum number. It has only two values, either plus 1 by 2 or another one we have minus 1 by 2. Next one is magnetic angular momentum, m of j. Again, m of j is represented with two values, minus j2 plus j. Or how many number of values it is taking? It is taking 2j plus 1 values. It is taking. This is about magnetic total quantum number. So this is very, very important question. What is the question we discussed? We discussed the question is vector atomic model, 10 marks question. This question is 10 marks. What is the question? Vector atomic model. What are the things we covered in vector atomic model? Principal quantum number, orbital quantum number, spin quantum number, total angular momentum quantum number. Fourth, next fifth one we discussed magnetic orbital quantum number, magnetic orbital quantum number. Next sixth one is magnetic spin quantum number is the sixth one. Next seventh one is magnetic total quantum angular momentum 7. Learn this question. This is very important 10 marks question. Next topic we have Frank Hertz experiment. What is the next topic? Next topic is Frank Hertz experiment, which is page number 15 or topic 1.7. This is 5 marks important question. 5 marks important question. Topic name is Frank Hertz. Frank Hertz experiment. In Frank Hertz experiment, first suppose the electron is in the ground state. The electron is in the ground state. I want to shift this one to the excited state. So I want to shift this from ground state to the higher energy level state. Shifting from ground state to higher energy level state is called as the term excitation. So what is the meaning of excitation? Shifting of electron from ground state to higher state is called excitation. In this excitation, the electron, if excitation is high, electron is knocking from the atom. Suppose here one atom. In this atom, electron is coming outside. So by excitation of energy, electron is knocking out from the atom. This process is called as ionization. What is ionization? By excitation, electron is coming out of the atom. If electron is coming out of the atom, we will call it as the ionization. And whatever the potential is required for the ionization, that is called as critical potential. Next, so here total I am using 3 terms. First term is excitation. Second term I am using ionization potential. Second term I am using ionization potential. Third term I am using critical. The potentials that are required for this process. The potential that is required for this process is called as what? Critical potential. Next one is critical potential. So as we observed in Bohr atomic model, in H alpha line, actually this is H alpha line, this is H alpha line, this is H beta line, this is H gamma line. If we observe the spectrum of H alpha, there are 2 lines are visible in H alpha. Very 2 closed lines are visible in H alpha. Suppose this is H alpha. Very 2 closed lines are visible in H alpha line. The distance between these 2 lines is of the order of 0.13. Uh, 0.13. Suppose next in the second paragraph, what is explained? For one atom, there is only one ionization potential. For one atom, there is only one ionization potential. Ionization potential is only one. Ionization potential is one, but more number of excitation potentials. Excitation potentials. Only for the atom, there is only one ionization potential is only one, but more number of excitation potential. Suppose here I have more number of atoms. If more atoms means, suppose to remove first electron from the atom, removing first electron from the atom, that is called first ionization potential. If I am removing second electron from, if I am removing first electron, removing first ionization. Suppose I am removing second electron. Second electron, if I am removing, it is called as second ionization potential. Now we will see Frank Hertz experiment. What he is explaining in Frank Hertz experiment. In Frank Hertz experiment, there is a glass tube. Okay. Glass tube. In this glass tube, one side is a plate P is there. One side, plate P is there. And in the next beside we have anode. Anode is represented with dots. We have anode. Next, another side, filament is there. Filament F. This filament F is connected to battery. Filament F is connected to battery. Positive terminal and negative terminal of the battery. This battery is represented with P1. This is a glass tube T. To this anode, to filament, another battery is connected. This anode to filament. Another battery is connected. Where anode I have to keep, I am keeping this anode terminal as a positive. Next, here there is other the other end of the plate is connected to milliammeter. The other end of the plate is connected to where? Milliammeter. The other end of the milliammeter is connected to battery, positive and negative. So, actually what happens across the battery B1, I want to apply potential 0 to 10 volts. Then when it is conducting, when the electrons is flowing towards the anode, the electrons is flowing towards the anode and it is falling on the plate P. When the electron falls on the plate P, it produces current. Then when it starts conducting, it depends upon your battery B3. Suppose I am taking example. Suppose I am taking battery voltage 0 volts. So it will not conduct. Current will not flow up to 3 volts. After 3 volts only the current will flow. So suppose imagine I am taking potential or voltage across the battery B1. Current, voltage versus current I am writing. Suppose I am taking a tabular column. Imagine the tabular column is voltage versus current. Where I am taking this current is represented with I, and whatever the voltage I am taking, that voltage I am varying across B1. Uh, Suppose different voltages I am taking 0, 1, 2, 3, 4, 5, imagine 6, 7, like I am taking. So current will not flow up to which voltage? Up to the battery voltage. It will not conduct. 3 volts వరకు current 0 నే ఉంటుంది. Because to flow electrons from this filament to the anode towards the plate, we need some minimum supply voltage from the battery 3. After this minimum supply voltage only, it will be conduct. So from 3 voltage, it will start conduct because B3, I took 3 volts. B3, I took 3 volts. So from 3 volts only, it will start conduct like 1, current 1, 20, 40, 70, 80, 100, so on. So it will conduct from this. Then how the graph represents? Here, the graph is represented with voltage versus current. The voltage is called as accelerating voltage versus current. I said current is increasing, but in the graph it shows us increasing and decreasing, again increasing, again decreasing, again increasing. So why we are getting this negative portion? Because the electrons is colliding with the mercury atoms. The electrons is colliding with the mercury. So when as we have mercury gas in this tube, these electrons are colliding with mercury gas. At that time, what happens? Its energy is lost. If energy is lost, it is falling. First accelerate అవుతుంది. Electrons accelerate అయినప్పుడు ఇది increase అవుతుంది. Electrons accelerate అయినప్పుడు increase అవుతుంది. Next కింద రాసి. Up to 3 or some, it will not conduct initially. Battery B3 వరకు తర్వాత increase అవుతుంది. తర్వాత decrease అవుతుంది. This decreasing part we are getting, these electrons are colliding with mercury gas and it is losing its energy. After some time, it again gets the energy and again it will increase. Again colliding with mercury gas, decreasing. Again increasing. At which point it is decreasing? First point of decreasing is 4.9 volts. First ionization potential is 4.9 volts. Next time where it is decreasing, next time it is decreasing across 9.8 volts. Here, whatever the x-axis I am using, this is accelerating potential, means voltage. Whatever the y-axis I am taking, this one is collector current. Whatever the y-axis I am taking is collector current. So here, in this answer, first introduction, what is ionization potential, what is critical potential, what is excitation, has to explain the first paragraph. Again, in the second paragraph, description of the diagram and how it is working. Next, from this graph, we have to make few conclusions. What is the first conclusion? Up to certain potential, no current is observed. Initially, current is 0. If initially current is 0 కాకపోతే గ్రాఫ్ ఎట్లుంటుంది? డైరెక్ట్ ఇక్కడ నుంచి స్టార్ట్ అవుతుంది. కానీ అట్లా కాదు కదా, ఇనిషియల్లీ కరెంట్ ఇస్ 0. Initially current is 0. Up to certain point, current is 0. Afterwards only it is starting. So from which point it is start is depends upon the battery B3. That is first point. Next second point ఏముంది? Next in the second point, voltage, dropping of voltage. Voltage drop ఎక్కడ వస్తుంది? ఒకటి 4.9 volts దగ్గర, ఇంకోటి 9 volts దగ్గర voltage drop అవుతుంది. Next ఏంటి? The main drawback of this experiment is we cannot distinguish which is excitation, which is ionization potential. So I said two types of potential. What is the first potential? First potential is excitation. Second potential, another term I used, ionization potential. We cannot differentiate which potential is excitation potential, which is ionization potential. This is the drawback. This is the drawback. We cannot distinguish excitation potential and ionization potential. So Unit 1 is completed. Just an overview what we discussed in Unit 1. In Unit 1, a vector atomic model is completed. After vector atomic model, from the graph, it will not conduct up to certain voltage. Up to the value of P3, it will not conduct. Again, there is a drop in potentials across 4.9 volts. Another drop is across 9.8 volts. That is the second point. Next, 4.9 is called as first critical potential. Next, across 9.8 is called as second critical potential. Drawback is we cannot distinguish excitation and ionization potentials. This is about the first unit. In the first unit, what are the topics we discussed? Just a quick recall. In Unit 1, Bohr and line spectrum. We discussed what is line spectrum, what is Bohr theory and derivation of Bohr energy equation derived చేసాము. Next, Sommerfeld. Next, energy level diagram, hector atomic model and Frank-Hertz experiment is completed. Now we will go to the Unit 2. What is Unit 2? Unit 2 is the molecular spectra. Unit 2, what are the topics we have? In Unit 2, we have correspondence principle. First topic is correspondence principle. Second topic we have what are the quantum numbers we have. Next, third topic is Pauli's exclusion principle. Next one is periodic table elements. Next one is the molecular spectra. So today we will discuss these 5 topics. First, we will see what is correspondence principle. So objectives of this chapter is correspondence principle, Pauli's exclusion principle, and we will see what is molecular spectra, and we will see discuss about the periodic table and Pauli's exclusion principle. First, in the introduction, as Bohr said, Bohr explained hydrogen spectrum. Bohr correspondence principle and spectrum. Suppose if we are getting spectrum by the atoms, మనకు స్పెక్ట్రమ్ వస్తుందా? ఈ స్పెక్ట్రమ్ అనేది మనకు ఆటమ్స్ వల్ల వస్తే దాన్ని ఆటమిక్ స్పెక్ట్రా అంటాం. సపోజ్ సేమ్ స్పెక్ట్రమ్, ఇప్పుడు ఈ స్పెక్ట్రమ్ మనకు దేని వల్ల వస్తుంది? ఆటమ్స్ వల్ల వస్తుంది. ఇఫ్ యూ ఆర్ గెటింగ్ స్పెక్ట్రమ్ ఆఫ్ because of atoms, this is called as atomic spectra. Suppose if you are getting spectrum of due to molecules, we will call it as a molecule. 2 types of spectra, whether it is atomic spectra or molecule spectra. If the spectra is due to atoms, it is called as atomic spectra. Spectrum is due to atoms. Atoms valla spectrum vaste adi atomic spectrum. The spectra is getting due to molecules. The spectrum is getting due to molecules, it is called as molecular spectra. So the most common types of spectrums we will observe is observed in the 3 regions. What are the 3 regions we will observe? One is microwave region, another one is far infrared or microwave or far infrared region. Another we will observe in near infrared region. Another, we can see the spectrum either in the visible region or UV region. Next, spinning. Spinning of electron is proposed by Gaudsmith and Uhlenbeck in the year 1925. He explained this spinning concept in double line structure of the alkali metals. Next, we will see the quantum numbers. What are the quantum numbers we have? Before discussing quantum numbers, the orbits is playing very important role in developments of the atomic structure. Very important way in the development of what is Sommerfeld theory said? Sommerfeld theory said the orbitals are in elliptical. Whereas both said the orbitals are in circular. ఇది elliptical shape లో ఉంటుంది. ఓకే. సపోజ్ n ఈక్వల్ టు 1 ఉంది అనుకోండి. ఫస్ట్ డయాగ్రామ్. సపోజ్ n ఈక్వల్ టు 1 ఉంది. అప్పుడు l ఈక్వల్ టు n-1 అంటే ఇప్పుడు l ఏమవుతుంది? 0 అవుతుంది. l 0 అంటే s ఆర్బిట్ లో ఉన్నాము. అప్పుడు మనం ఎట్లా రాస్తాము? 1s అని రాస్తాం. 1s అని రాస్తాం. దాని డయాగ్రామ్ ఎట్లుంటుంది? ఓన్లీ సర్క్యులర్ షేప్ లో ఉంటుంది. ఇక్కడ ఒక న్యూక్లియస్ ఉన్నది, ఇక్కడ ఒక ఎలక్ట్రాన్. 1s కి డయాగ్రామ్ అయిపోయింది. నెక్స్ట్ n ఈక్వల్ టు 2 కి చూద్దాం. n ఈక్వల్ టు 2. n ఈక్వల్ టు 2 ఉన్నప్పుడు l ఈక్వల్ టు n-1 అంటే ఎంత? l ఈక్వల్ టు 2 - 1 1 అంటే l ఎంత వచ్చింది? l1 వచ్చింది. l1 ఉందంటే ఏంది? p ఆర్బిటాల్ లో ఉన్నాం. n ఈక్వల్ టు 2, l ఈక్వల్ టు 1, l ఈక్వల్ టు p వచ్చి అంటే ఏంటి? l 0 అని ఉండొచ్చు, l 1 అని ఉండొచ్చు. l 0 ఉన్నప్పుడు ఏమొస్తుంది? s ఆర్బిటాల్ లో ఉన్నది. p లో ఉన్నప్పుడు l 1 ఉన్నప్పుడు p లో ఉంది. ఇప్పుడు మనం దీన్ని ఎట్లా రాస్తాం? 2 ఆప్షన్ లో రాస్తాం. దీన్ని ఎస్పీని ఎట్లా రాస్తాం? n కదా, n అంటే 2 s, ఇంకోటి ఎట్లా రాస్తాం? 2 p రాస్తాం. ఇప్పుడు దీనికి 2 వస్తాయి చూడండి. ఒకటి సర్కిల్ షేప్ లో వస్తుంది, ఇంకోటి ఎలిప్టికల్ ఆర్బిట్ షేప్ లో వస్తుంది. ఈ సర్క్యులర్ షేప్ కి నేను ఇక్కడ బోర్డ్, వైట్ బోర్డ్ యూస్ చేద్దాం. I'm writing for n equal to 2. n equal to 2 అంటే l equal to n-1, which implies 2 - 1. l అనేది 1 ఉంటుంది. l equal to 1 అంటే మనం p తీసుకుంటున్నాం. సో l 0 ఉండొచ్చు, 1 కూడా ఉండొచ్చు. l 0 ఉన్నప్పుడు s, l 1 ఉన్నప్పుడు p. సో పాసిబుల్ కాంబినేషన్స్ ఏమొస్తున్నాయి? 2s 2p వస్తుంది. ఇప్పుడు 2s కి డ్రా చేస్తాను. 2s కి దీని ఫీచర్స్ ఏంటి? n equal to 2, n equal to 0. This is the diagram for 2s. Next 2p. 2p. We are writing for 2p. 2p లో n ఎంత? 2, l ఎంత? 1, 1 equals pr. pr. Suppose n 3 తీసుకున్నా. n 3 తీసుకుంటే l 2 ఉంటుంది. అంటే ఏమేంటివి? 0, 1, 2, 3 ఆప్షన్స్ ఉన్నాయి. ఇది s, ఇది p, ఇది t ఉంది. దీని అప్పుడు ఏం రాస్తాం మనం? 3s, దీన్ని 3p రాస్తాము, దీన్ని 3d రాస్తాం. సో 3 సర్కిల్స్ వస్తాయి. ఫస్ట్ ఎల్ ఇది జీరోకి, ఇది ఎల్ 1కి. ఎల్ ఈక్వల్ 0 ఉన్నప్పుడు మనకి ఏమొస్తుంది ఇక్కడ 3s వస్తుంది. ఎల్ 0 ఎల్ 3 ఇది సర్కిల్ షేప్. ఎల్ ఈక్వల్ 1 అంటే 3p వస్తుంది. ఎన్ ఈక్వల్ టు 3 వస్తుంది. ఎల్ ఈక్వల్ టు 2 ఉన్నప్పుడు ఎన్ ఎంత వస్తుంది? ఎన్ ఈక్వల్ టు 3 వస్తుంది. దీన్ని మనం ఎట్లా రాస్తాం? 3dగా రాస్తాం. 3. సో ఇది ఎన్, ఈ మొత్తం డయాగ్రామ్ ఏమో ఎన్ ఈక్వల్ టు 2కి, ఇది మొత్తం ఏమో ఎన్ ఈక్వల్ టు 2కి. ఇది మొత్తం దేనికి డ్రా చేస్తాం? ఎన్ ఈక్వల్ టు 3కి డ్రా చేస్తాం. నెక్స్ట్ ఎన్ ఈక్వల్ టు 1కి కూడా చూద్దాము. ఎన్ ఈక్వల్ టు 1 అంటే ఒకటే సర్కిల్. ఎన్ ఈక్వల్ టు 1, ఎన్ ఈక్వల్ టు 0 అంటే 1s. దిస్ ఈస్ అబౌట్ క్వాంటమ్ నంబర్ స్ట్రక్చర్. నెక్స్ట్ మనము సపోజ్ సోడియంకి చూద్దాం. సోడియం ఎలక్ట్రాన్ 1s2, 2s2, 2p6, 3s1. 1s ఎన్ని వస్తుంది మనకి ఇక్కడ ఆర్బిటాల్స్? 1s, ఇది 2s, ఇది 2p, ఇది 3s. సో సింగిల్ ఎలక్ట్రాన్ ఎక్కడుంది? 3s. సింగిల్ ఎలక్ట్రాన్ ఇస్ అక్రాస్ థర్డ్ వన్. ఇదేంటి? ఇది 1s. ఇదేంటి? 2s2 అంటే ఒకటి ఇట్లా పెడతాం కదా మనం. ఇది 2p. ఇది ఏంది? 2p లైన్. పీలో ఎన్ని ఉంటుంది? 6 ఉంటుంది. ఒకటి అప్, ఒకటి డౌన్ సెట్, ఒకటి అప్, ఒకటి డౌన్, ఒకటి అప్, ఒకటి డౌన్. So this is for sodium atom, atomic model of the sodium. This diagram is atomic model of the sodium atomic model. నెక్స్ట్ మనకు సపోజ్ మనము బామర్ సిరీస్ హైడ్రోజన్ ఆటం చూద్దాం. బామర్ సిరీస్ లో హైడ్రోజన్ ఆటమ్ లో మనకి విజిబుల్ లో మనం స్పెక్ట్రమ్ లో చూస్తే 2 లైన్స్ లాగా కనిపిస్తుంది. ద డిస్టెన్స్ బిట్వీన్ 2 లైన్స్ ఎంత ఉందంటే హెచ్ ఆల్ఫా అనుకోండి. ఇది యాక్చువల్ హెచ్ ఆల్ఫా మనకి వెరీ 2 క్లోజ్డ్ లైన్స్ గా కనిపిస్తుంది. దీని డిస్టెన్స్ ఎంత ఉందంటే 1.59 ఆంగ్స్ట్రమ్స్. ద డిస్టెన్స్ బిట్వీన్ దీస్ టూ ఇస్ 1.59 ఆంగ్స్ట్రమ్స్. సో this is about which one we discussed about the quantum numbers is completed. This quantum orbital quantum number, the orbital quantum number is represented with P of s. Orbital quantum number is represented with P of s is equal to s times of h by 2 pi. Spin quantum number is this. Orbital quantum number P of l equal to l times of h by 2 pi. Next, this M of L equal to plus L to minus L. We already discussed this one. So this is about quantum numbers. Next we will see Pauli's exclusion principle. The main topic is missed. Correspondence principle. What is this correspondence principle? Actually, what next one we have to discuss very important 5 marks question is afterwards we will go for the Pauli's exclusion principle. Next one is correspondence principle. Actually, Bohr proposed the theory of hydrogen atom. Bohr proposed hydrogen atom. For both Bohr చేసిండు hydrogen atom ని propose చేసిండు. Both combining of classical theory as well as quantum theory. It is a combination of classical theory as well as quantum concepts. So this two. So the predictions of classical is making equal to the prediction of quantum. ఈ రేంజ్ ని ఈ రేంజ్ కి రెండింటిని ఒకటే కోణంలోకి తీసుకురావడం అనమాట. క్లాసికల్ అండ్ క్వాంటమ్ రెండింటి ప్రెడిక్షన్స్ ని ఈక్వివలెంట్ చేయాలి. దిస్ ఈస్ పాసిబుల్ ఓన్లీ ఫర్ ద హైయెస్ట్ వాల్యూ ఆఫ్ క్వాంటమ్ నంబర్. హైయెస్ట్ వాల్యూ possible only for the highest value of quantum number. The predictions of classical, the predictions of classical made almost equal to the predictions of quantum. The predictions of classical almost brought together to the of now we will see the PDF. What is explaining in correspondence principle? This correspondence principle is 5 marks important question. Bohr proposed the theory of hydrogen atom by combining both classical and quantum concepts. So it is a combination of both classical and quantum. When the atomic number n is very large, suppose n is very large, what happens? The spectrum lines are very, very near. N principal quantum number n అనేది infinity ఉంది అనుకోండి. So the spectral lines ఏమేస్తుంది? Very, very, very near. The spectrum lines are very near. Up to the so the are crowded together so that the spectrum appears almost continuous. N value greater than అనుకోండి మనకు continuous spectrum వస్తుంది. This behavior makes to come of the correspond. ఈ దీని వల్ల స్పెక్ట్రమ్ లైన్ అనేది మనకు కంటిన్యూస్ స్పెక్ట్రమ్ లైన్ వస్తున్నందుకు బోర్ అనేది ఈ కరెస్పాండెన్స్ ప్రిన్సిపల్ ని తీసుకొచ్చిండు. వాట్ దిస్ ప్రిన్సిపల్ సేయింగ్? దిస్ ప్రిన్సిపల్ స్టేట్స్ దట్ ఇక్కడ నుంచి డెఫినేషన్. ద ప్రిన్సిపల్ స్టేట్స్ దట్ the predictions of the quantum theory behavior is corresponding to the limit of the quantum theory. Means the predictions of the quantum theory is made almost equivalent to the predictions of the classical theory. This is possible only when there is a large number of quantum number. Quantum number n value large ga unnappudu maatrame ee possibility undi. If n equal to large, if n equal to large, quantum predictions ni classical predictions toti match cheyochu. Classical predictions ni quantum predictions can be matched. This predictions is only possible for the large value of n. On next part, classical electromagnetic theory predicts that the frequency of the emitted radiation. So this classical theory, what it is saying? The frequency of the emitted radiation is equal to the frequency of the revolution. This is about the correspondence principle. So just remember one important, very, very important point. The classical predictions of the classical is made almost matching to the predictions of the quantum. This is possible only for the higher value of the principal quantum number. What is the purpose of prescribing, suggesting this one? This correspondence principle is suggested because of the spectrum lines is very, very closer. The spectrum lines are very, very closer. This very close spectrum lines is possible only for the higher value of n. So this is correspondence principle. Next, the quantum numbers is also completed. This is for sodium atom. A sodium atom, this is 1s. This orbital is 2s. This orbital is 3s. This is 2p. This is 2p. What is sodium configuration? 1s2, 2s2, 2p6, 3s2. So four, totally four. One circle. One side, other side, other side. Total 4. Next formulas. This one already we discussed. Next is Pauli's exclusion principle. What is the range of values it is taking? In the previous only we discussed principal quantum number, orbital quantum number, magnetic quantum number, spin projection quantum number. Which values it is taking is explained in Pauli's exclusion principle. In the Pauli's exclusion principle, first one is the principal quantum number. Principal quantum number is represented with n. N is equals to 1 to infinite. N values is from where? N is equal to the principal quantum number. N values is from 1, 2, 3, 4, so on. It will take infinity. Next one is what? L. L is orbital quantum number. L equal to n minus 1. Suppose my n equal to 5. L is equals to how much? 4. L equal to 4. Next, third one, ML. ML is magnetic quantum number. It is taking values from minus L to plus L. Next, MS. It is taking plus S to minus S. S is only two values, either it is plus 1 by 2 to minus 1 by 2. All these things comes under Pauli's exclusion principle. Here, definition of Pauli's exclusion principle is important. What is the definition of Pauli's exclusion principle? No two electrons. Definition compulsory we have to mention. No two electrons can exist in an atom in the same electron state. According to the Pauli's exclusion principle, no two electrons can exist in an atom. In the same electron state, two electrons no two electrons is exist. Suppose if L value is 0, what is this shell? S. If L equal to 1, P. L equal to 2, D. If L equal to 3, these are in where hydrogen atom. All these are in hydrogen atom. If suppose in X-rays, there we represent K shell, L shell, M shell, N shell. For electronic hydrogen atom, we will represent in terms of S, S, P, D, F. How many values L will take? L will take 2 times of 2L plus 1 values. L is to be. Suppose L1 అనుకోండి. L1 పెడితే ఏమవుతుంది? టేబుల్ రాద్దాం. టేబుల్ ఎక్స్ప్లెయిన్ చేస్తాను. L plus 2 times of 2L plus 1 values L తీసుకుంటుంది. Now I will explain the table. Suppose n. Look at the table, what is given in this table? Suppose n 1 ఉంది. L ఎంత వస్తుంది? n minus 1 కనుక ఇది 0 వస్తుంది. ml ఎంత వస్తుంది? ప్లస్ l టు మైనస్ l అంటే 0నే ఉన్నది. స్పిన్ ఏముంటుంది ఇక్కడ? స్పిన్ అనేది +1/2 ఉండొచ్చు, -1/2 ఉండొచ్చు. ఈ 2 ఆప్షన్స్. +1/2, -1 ఉండొచ్చు. ఇప్పుడు నంబర్ ఆఫ్ ఎలక్ట్రాన్స్ కి ఫార్ములా ఏంటి ఇక్కడ? 2 times of 2l plus 1. 2 times of 2l plus 1. l అనేది 0. అంటే ఏమొస్తుంది? సబ్స్టిట్యూట్ చేస్తే 0, ఫస్ట్ టర్మ్ 0 అయిపోతుంది. నంబర్ ఆఫ్ ఎలక్ట్రాన్స్ 2 ఉన్నాయి. నెక్స్ట్ టోటల్ నంబర్ ఆఫ్ ఎలక్ట్రాన్స్ ఫార్ములా అయింది 2n². టోటల్ నంబర్ ఆఫ్ ఎలక్ట్రాన్స్ ఇది ఎన్ని ఉన్నట్టు? 2 ఉన్నట్టు. ఇప్పుడు మనం n = 1 కి కంప్లీట్ చేస్తాం. నెక్స్ట్ n2. n2 తీసుకుంటే l ఏమొస్తుంది? 1 వస్తుంది. l 1 ఉన్నప్పుడు ఐదర్ 0 అని ఉంటుంది, 1 అని ఉంటుంది. 2 ఆప్షన్స్ ఉన్నాయి ఎల్కి. ml 0 ఉన్నప్పుడు మళ్ళీ మనకి ఇది 0నే ఉంటుంది. ఇది -1, 0, +1 ఉంటుంది. ఇక్కడ ml అయిపోయింది. ఇక్కడ ms ఏముంటుంది? +1/2, -1/2. ఇక్కడ ఫస్ట్ -1/2 వచ్చింది కనుక -1/2 +1/2 ఉంటుంది. నంబర్ ఆఫ్ ఎలక్ట్రాన్స్ ఇన్ ద షెల్ ఎంత? ఇక్కడ l 0 ఉన్నప్పుడు ఇక్కడ నంబర్ ఆఫ్ ఎలక్ట్రాన్స్ 2 ఉంటుంది. ఇప్పుడు l = 1 సబ్స్టిట్యూట్ చేస్తే ఇక్కడ 2 + 1 3 2 6 అవుతుంది. ఇక్కడ ఇక్కడ ఫార్ములా ఇక్కడ రాస్తున్నాను. 2 × 2l + 1 నుంచి వస్తుంది అనమాట. ఇది నంబర్ ఆఫ్ ఎలక్ట్రాన్స్ ఫార్ములా ఏంటి? 2 × 2l + 1 వస్తుంది. ఇంకా టోటల్ నంబర్ ఆఫ్ ఎలక్ట్రాన్స్ ఏంది? 2² 4 2 8 అంటే ఈ రెండింటి కలిపి నంబర్ ఆఫ్ ఎలక్ట్రాన్స్ అనేది 8 అవుతుంది. నంబర్ ఆఫ్ ఎలక్ట్రాన్స్ ఇందులో కూడా 8 ఉన్నాయి, ఇందులో కూడా 8 ఉన్నాయి. సో ఈ రెండు ఇప్పుడు దేనికి చేస్తాం మనం ఎక్స్ప్లెనేషన్? n = 2కి చేస్తాం. n = 3కి చూద్దాం. n = 2కి అయిపోయింది. నెక్స్ట్ ఇక్కడ రాస్తానమ్మా మిగతాది. n 3 తీసుకున్నా. ఇప్పుడు n ఎంత తీసుకున్నా? 3 తీసుకున్నా. n 3 తీసుకుంటే ఎల్లో ఏమేమి ఆప్షన్స్ ఉంటాయి? 2 వరకు ఉంటుంది. 0 ఒకటి ఉంటుంది, 1 ఒకటి ఉంటుంది, 2 ఒకటి ఉంటుంది. అప్పుడు మనకి నెక్స్ట్ ఎంఎల్ ఏమొస్తుంది? 3 2 కనుక -2 నుంచి +2 వరకు ఉంటుంది. -2 నుంచి +2 వరకు ఉంటుంది. -2 -1 0 1 2 ఉంటుంది. ఇక్కడ -1 0 1 ఉంటుంది. ఇక్కడ 0 ఉంటుంది. ఇప్పుడు వీటికి స్పిన్స్ ఏం రాస్తాం? స్పిన్ దీనికి +1/2, దీనికి -1/2, దీనికి -1/2 +1/2, దీనికి -1/2 +1/2. ఎంఎల్ అయిపోయింది, ఎంఎస్ అయిపోయింది. ఎంఎల్ అయిపోయింది, ఎంఎస్ అయిపోయింది. నెక్స్ట్ నంబర్ ఆఫ్ ఎలక్ట్రాన్స్. నంబర్ ఆఫ్ ఎలక్ట్రాన్స్ ఫార్ములా ఎంత? 2l + 1. l 0 ఉన్నప్పుడు ఇక్కడ 2 వస్తుంది. l 1 ఉన్నప్పుడు 3 6 వస్తుంది. l 2 ఉన్నప్పుడు 2 to the 4 5 10 వస్తుంది. 10 ఎలక్ట్రాన్స్ ఉంటాయి. టోటల్ నంబర్ ఆఫ్ ఎలక్ట్రాన్స్ ఎందులో? 2n². n అంటే 3 3² 9. టోటల్ నంబర్ ఆఫ్ ఎలక్ట్రాన్స్ 18. సో ఈ సెట్ మొత్తం this set is completely for n = 3. This set is completely for which one? This set is completely for n = 3. Next, the first line, this is for n = 1 set. Next, this is for, next we will see n = 4, which is given in the table, page number 25. And next n = 4 ki chuddam. If n = 4, if n = 4, what are the possibilities we have? N, L, ml, ms, number of subshells, number of subshells, total number of electrons, total number of electrons, L, ml, ms, N4 అంటే 0 ఉంటుంది, 1 ఉంటుంది, 2 ఉంటుంది, 3 ఉంటుంది. ఇది సేమ్ ఇంకా 0, -1, 0, 1 ఇక్కడ -2, -1, 0, 1, 2 ఇక్కడ -3, -2, -1, 0, 1, 2, 3. దీన్ని బట్టి రాయొచ్చు. నెంబర్ ఆఫ్ షెల్స్ ఎంత? 2. ఫార్ములా ఏంటి? 2 టైమ్స్ ఆఫ్ 2l + 1. L 0. L 0 ఉన్నప్పుడు 2 ఉంటుంది, L 1 ఉన్నప్పుడు 6 ఉంటుంది, L 2 ఉన్నప్పుడు 4 10 ఉంటుంది, L 3 ఉన్నప్పుడు 3 to the 6 + 1 7 to the 14 ఉంటుంది. L 3 ఉన్నప్పుడు 14 ఉంటుంది. టోటల్ నెంబర్ ఆఫ్ ఎలక్ట్రాన్స్ ఫార్ములా ఏంటి? 2n². n అంటే 4 square 16 to the 32. సో నంబర్ ఆఫ్ ఎలక్ట్రాన్స్ ఇక్కడ ఏమొస్తుంది? 32 వస్తుంది. ms ఏంటి? ఐదర్ +1/2 -1/2. ఇక్కడ +1/2 -1/2 ఉంటుంది. ఇక్కడ ఫస్ట్ మైనస్తో స్టార్ట్ అయింది కనుక -1/2 +1/2. ఇక్కడ -1/2 +1/2. ఇక్కడ -1/2 +1/2. So this is about Pauli's exclusion principle is completed. In the next class, we will see the periodic table of elements and the molecular spectra of or rotational and vibrational spectra. We will see this one in the next class.